A flat surface of area 3.20 meter square is rotated in a uniform electric field of magnitude E equal to 6.20 times 10 power 5 Newton per Coulomb. Determine the electric flux through this area when electric field is perpendicular to the surface, that is the first case, and when electric field is parallel to surface. So we are rotating a surface in an electric field. Suppose let me draw the electric field first line. So these are the electric field lines. By convention, they are along positive x-axis, or you can take unit vectors along I cap. So that is the electric field vector. Now, and if I take a surface, suppose this is the surface. Now this surface is having area A equal to 3.20 meter square. Now in the first case, the electric field is perpendicular to surface area. Area is a vector. Suppose if I show the area vector along in this direction, so this is the area vector. The electric field is making an angle with 90 degrees with electric field vector. So this is the A bar and this is A bar. Now in the first case, we need to figure it out what is the flux. So electric flux formula phi suffix E equal to E bar dot A bar, which equal to E times A cos theta. Now when E bar is perpendicular to A bar, then theta equal to 90 degrees, because electric field is exactly perpendicular to the surface area. Now it's easy. You can substitute what the given values. Electric field is 6.20 times 10 power 5 Newton per Coulomb times area 3.20 meter square times cos 90. So cos 90 value will become 0. So electric flux pi equal to 6.20 times 10 power 5 Newton per Coulomb times 3.20 meter square times cos 90 value 0. The flux in the first case will become 0. For the second case, that is when the electric field is parallel to surface. Suppose if you take the electric field, so in this electric field, if you take a surface which is parallel to the electric field. So if I take a surface which is parallel to electric field, so if you can rotate the surface, let it be that. So the area vector now is along in this direction. Now the area vector, if you can draw area vector, so the area vector is along in this direction. Now electric field vector and area vector, they are in both the direction. So for the second case, E bar is parallel to A bar. What is the angle between them? Theta equal to 0 degree. So if you can do the flux for the second case equal to flux pi E equal to E dot A, which equal to E A cos theta. Substitute the values. The electric field value, which is given that 6.20 times 10 power 5 Newton per Coulomb, 6.25 10 power 5 Newton per Coulomb times area 3.20 meter square. 3.20 meter square and cos 0 degree. Cos 0 degree value goes to 1. So you can substitute the cos value over there, times 3.20 meter square, cos value was to 1. So the flux through the surface, if you can multiply that value, if you multiply to get the value, you can get the value 1.98 times 10 power 6 Newton meter square per coulomb. So this is the flux in the second case.